Welcome to Bethlahem Institute of Engineering. Bethlahem Institute of Engineering is affiliated to Anna University, Chennai and approved by AICTE, New Delhi. This institution was established in the year 2008.
Very good morning to you all. Now we are going to see about overlap add method and overlap save method. In convolution there are several methods are there to find to convolve two sequences. Now we are going to see about overlap add method and overlap save method. Okay. So for convolution we need two sequences. One is first sequence is denoted as x of n, and the second sequence or impulse response is denoted as h of n. Okay, there are several steps to find convolve two sequences. Step 1, determine length m, which is the length of the impulse response data sequence, that is h of n, and determine m minus 1. Okay, in this the x of n is a larger sequence and h of n is the smaller sequence. Okay, in this m is the number of samples in smaller sequence or impulse response. Okay, so in this we have to know about the number of samples in smaller sequence and then determine m minus 1. In step 2, given input sequence x of n, size of DFT is n. Let us assume n is equal to 5. Okay. In step 3, determine the length of the new data. Okay, the length of the new data is denoted as L. Okay. In step 4, we have to pad m minus 1 number of zeros to x of n and L minus 1 number of zeros to h of n. That means m minus 1 number of zeros to the longer sequence and L minus 1 number of zeros to the smaller sequence. That means the impulse response. Okay. So in overlap add method, the input data sequence x of n is subdivided into subsequences. That are the length of the new data will be L. Okay, so x of n is subdivided into x1 of n, x2 of n, x3 of n and x4 of n. And in that we have to pad m minus 1 number of zeros in every sequences. Okay, so then after that we have to convolve the two sequences. That means the x of n is subdivided in the x1 of n, x2 of n, x3 of n and x4 of n. In this step we have to convolve each x of n with h of n. That means x1 of n with h of n and x2 of n with h of n, x3 of n with h of n and x4 of n with h of n. So y1 of n is equal to x1 of n circular convolution h of n. Likewise, y2 of n is equal to x2 of n circular convolution h of n. And y3 of n is equal to x3 of n circular convolution h of n. Likewise, y4 of n is equal to x4 of n circular convolution h of n. Okay. So in this overlap add method, in the last we can find y1 of n, y2 of n, y3 of n, y4 of n from this convolution outputs. So in this we have to find the y1 of n, we have to pad m minus 1 number of zeros at the last bit. In every stage we have to pad m minus 1 number of zeros at the last bit. Okay, let's see one example. In this overlap add method, let's see one example. The x of n is equal to 3 minus 1 0 1 3 2 0 1 2 1. This is the larger sequence and h of n is equal to 1 1 1. This is the smaller sequence. Okay, so in this smaller sequence, the number of samples in smaller sequence or the number of samples in impulse response is denoted as m. Okay, let n is equal to 5 and the length of h of n is equal to that means the length of impulse response is equal to m is equal to 3. Therefore m minus 1 is equal to 2. We know that one formula, n is equal to L plus m minus 1. In this, n is equal to 5 and m is equal to 3. From this we can find L is equal to 3. That means L is the number of bits in new data. Okay, so we pad L minus 1 number of zeros with h of n. That means in this given example, h of n is equal to 1, 1, 1. But we have to add L minus 1 number of zeros with h of n. So the h of n value becomes 1, 1, 1, 0, 0. Okay. In this overlap add method, first write the input sequence x of n. So 3, minus 1, 0, 1, 3, 2, 0, 1, 2, 1. Okay. In this, we have to subdivide this data sequence into x1 of n, x2 of n, x3 of n and x4 of n. Okay. So in this, first we have take m number of data from the x of n. So the data taken from this input sequence is 3, minus 1 and 0. Then we have to pad m minus 1 number of zeros with this x1 of n. So m minus 1 is equal to 2. So we have to pad 2 zeros with this x1 of n. Okay. Then in x2 of n, take the next 3 bits. 1, 3, 2. 1, 3, 2 and we have to pad m minus 1 number of zeros. Okay. Then in x of 3, we have to take next 3 bits that are 0, 1, 2 and we have to pad m minus 1 number of zeros. So 0, 0. In the fourth bit, the last 1 digit is there. So take this 1 and pad the remaining all the values as 0. Okay. So in this, the data sequence x of n is subdivided into x1 of n, x2 of n, x3 of n and x4 of n. In this, we are taking L number of bits from this x of n and we have to pad m minus 1 number of bits in every x1 of n, x2 of n and x3 of n and x4 of n. Okay. So in this next step, overlap add method, performing yk of n is equal to xk of n circular convolution h of n. That means y1 of n can be obtained by the circular convolution of x1 of n and h of n. Likewise, y2 of n is equal to x of n, x2 of n circular convolution h of n and y3 of n is equal to x3 of n circular convolution h of n. Likewise, y4 of n is equal to x4 of n circular convolution h of n. We can get the values. To get this circular convolution value, we can use matrix multiplication method. Okay. So simply we can get these values. So y1 of n is equal to 3, 2, 2, minus 1, 0 and y2 of n is equal to 1, 4, 6, 5, 2 and y3 of n is equal to 0, 1, 3, 3, 2 and y4 of n is equal to 1, 1, 1, 0, 0. Okay, then how to add this values using overlap add method? Now we are seeing the how to add these samples. Okay, so in this y1 of n we got the value 3, 2, 2, minus 1, 0. In this time we have to find the overlapping sequence. The formula to calculate the overlapping sequence is m minus 1. Okay, so in this given data, m is equal to, in this example, m is equal to 3. So m minus 1 is equal to 2. So we have to overlap 2 sample sequences. Okay, So m minus 1 is equal to 2. So we have to overlap two samples. Here also we have to overlap. We are overlapping two sequences. Here also we are overlapping two sequences with in this we are overlapping y2 of n with y1 of n. Then overlapping y3 of n with y2 of n and y4 of n with y3 of n. Okay. Now we overlapped. Then we have to add the values. So in this we can get the value 3, then 2, then 2. Next we have to add minus 1 and 1. Minus 1 plus 1 is equal to 0. Then 0 plus 4 is equal to 4. Then write 6. So we got the value as 322046. Then we have to add 5 plus 2. So 5, then 2 plus 1, 3, then 3, then 3 plus 1, 4, 2 plus 1, 4, then 1, 0, 0. Okay, so in this we can get the value as third stage addition, then in this fourth stage addition. So at last we can get the value 322046533431100. Okay, so this is the convolution value of the two sequences x1 of x of n and h of n. Okay. Okay, now let's see about overlap save method. In this overlap save method, the first step is determine the length m, which is the length of the impulse response data sequence, that is h of n, and determine m minus 1. Okay, in this also we are convolving two sequences, two data sequences. One is the data sequence and another one is the impulse response. Okay, the data sequence is represented as x of n and the impulse response is denoted as h of n. In this, the x of n is the longer sequence and h of n will be the smaller sequence. Okay, so the number of samples in h of n is denoted as m, and we have to determine m minus 1. Okay, so in steps 2, the given data sequence x of n, the size of DFT is n. Let us assume n is equal to 5. Okay, so in step 3, we have to determine the length of the new data. X of n is the given data and h of n is the impulse response. We have to subdivide that x of n into smaller sequences. So on the smaller sequences, determine the length of the new data. The length of the new data is denoted as capital L. So then L is calculated by using the formula n is equal to L plus m minus 1. Okay, so in this we can find using this we can find the value of L. In the step 4, we have to pad L minus 1 number of zeros to h of n. Okay, so L minus 1 number of zeros to h of n we have to pad. Okay, so in the h of n we have to pad L minus 1 number of zeros. So in overlap save method, the input data sequence x of n is subdivided into smaller subsequences. The length of the new data is denoted as L. Okay, so x of n divided into smaller sequences, x1 of n, x2 of n, x3 of n and x4 of n. In this we have to pad m minus 1 number of zeros in the first bit. Okay, so m minus 1 number of zeros we have to pad in every x1 of n, x2 of n, x3 of n and x4 of n, that subsequences. Okay, then we have to convolve the sequences. Already x of n is split into x1 of n, x2 of n, x3 of n, x4 of n. Then we have to convolve every sequence with h of n. Okay, so we can get y1 of n is equal to x1 of n circular convolution h of n, and y2 of n is equal to x2 of n circular convolution with h of n, y3 of n is equal to x3 of n circular convolution h of n, and y4 of n is equal to x4 of n circular convolution h of n. Okay, so this is the structure of overlap save method. In this we have to pad m minus 1 number of data. In this we have to discard the m minus 1 number of data. At the last position, last step, we have to discard m minus 1 number of data. In this overlap add method, we are overlapping m minus 1 number of sequences, samples, and we are adding that samples. But in this overlap save method, we are discarding m minus 1 number of samples in every y of n values. Okay, so in this we are discarding m minus 1 number of values. The final output data sequence will be y of n. Okay, let's see one example. In this overlap save method, let's see one example. The given data x of n is equal to 3 minus 1 0 1 3 2 0 1 2 1, and h of n is equal to 1 1 1. Okay, in this the x of n is the longer sequence and h of n is the smaller sequence. Okay, so m is denoted as number of samples in h of n. Okay, the number of samples in h of n. H of n is a impulse response or smaller sequence. We can say this is smaller sequence. Okay, so the number of samples in smaller sequence is m. Let take n is equal to 5. The length of h of n is equal to m is equal to 3. Therefore, m minus 1 is equal to 2. We know that n is equal to L plus m minus 1. In this, n is equal to 5 and m is equal to 3. From this, we can find L is equal to 3. So, we have to pad L minus 1, that is equal to 2 zeros with h of n. L is equal to 3. So, L minus 1 is equal to 2 number of zeros with h of n. So, the h of n becomes, h of n is equal to 1 1 1 0 0. So, in this we are writing the x of n, that is 3 minus 1 0 1 3 2 0 1 2 1. Okay, in this we are subdividing this x of n into x1 of n, x2 of n, x3 of n, and x4 of n. Okay, in this we are padding m minus 1 number of zeros. Here we are padding m minus 1 number of zeros. So m minus 1, the value of m minus 1 is equal, in this example is 2. So we are padding 2 values. Okay, in this next x2 of n, we are padding m minus 1 of previous data in this place. So in this m minus 1 is equal to 2 number of previous data. In this we are taking minus 1 and 0 from this previous data. So the data will be minus 1 0, and from these 3 values 1 3 2. Okay, 1 3 2. In this x3 of n, we are taking m minus 1 number of previous value. So the value m minus 1 is equal to 2. So we are taking 2 values 3 and 2 from this, and 3 and 2, and the next values are 0 1 2. Okay, then at last x4 of n, we are taking m minus 1 number of samples from previous, so 1 and 2, and the last bit is 1. Then there are 2 places are remaining. So in this place we are padding zeros. Okay, so in this place we are subsequenting x of n into x1 of n, x2 of n, x3 of n, and x4 of n. So in this next step, we are convolving this x1 of n, x2 of n, x3 of n, and x4 of n with h of n. Okay, so y1 of n is equal to x1 of n circular convolution h of n, and y2 of n is equal to x2 of n circular convolution h of n, and y3 of n is equal to x3 of n circular convolution h of n, and y4 of n is equal to x4 of n circular convolution h of n. Okay, so in this the circular convolution can be formed by using matrix multiplication method. So easily you can find the values using matrix multiplication method. So at last we have to save the values. So in this we are discarding m minus 1 number of samples. Okay, so in this values y1 of n, the value of y1 of n is minus 1 0 3 2 2. In this we have to discard m minus 1 number of bits. So the value of n minus 1 is equal to 2. So we are discarding two values, two samples, that are minus 1 and 0. At the next y2 of n also we have to discard 2 samples. So we are in this we are discarding 4 and 1. In the third step, in the y3 of n also we have to discard 2 values. So 6 and 7 also are discarded. In this fourth y4 of n we are discarding 1 and 3. Okay. So finally we can write the values as 3 2 2, 3 2 2, 0 4 6, 5 3 3 and 4 3 1. So we are writing the values are, we are discarding m minus 1 number of samples from every y of n, and we can write the remaining values. So 3 3 3, 3 2 2, 0 4 6, 5 3 3, 4 3 1. In every stage we can find 3 2 2, 0 4 6. In the next stage we can find 5 3 3. After that we can get 4 3 1. Okay, so this is the last final answer of convolving two sequences x of n and h of n. The given data x of n and the smaller data or impulse response h of n. Okay, so in this overlap add method we are overlapping m minus 1 number of samples and we are adding the sample values. Okay, in this overlap save method we are discarding m minus 1 number of samples. Okay, so the difference is, in this overlap save method we are discarding m minus 1 number of samples, but in overlap add method we are overlapping m minus 1 of number of samples and we are adding the sample values. Okay, finally we can get the answer y of n is equal to 3 2 2, 0 4 6, 5 3 3, 4 3 1. Okay, thank you.